In this video, we're going to look what happens to sine theta, tan theta, and cos theta when the angle measured in radians gets very, very small. So here we've got a graph. So it goes up to 1 here on the y-axis, and we've got different values of the angle measured in radians. So if we look at the graph of sine x, it's just looking at graphically. In a later video, I'll sort of prove these results to you. This is the graph of sine. Okay, so at pi by 2, it is equal to 1. Now, if we compare that with the graph of y is equal to x, we will see right down here, that the two graphs almost coincide. And therefore, we can say for small theta, sine theta is approximately equal to theta. All right, so it normally is about between minus 0.1 and 0.1 is sort of the range. Okay, if we also put on there the graph of tan, so this is the graph of tan, then we will also see that for small theta, okay, it will approximate to theta. So for small angles, sine theta is approximately, small angles measured in radians, sine theta is approximately equal to theta, and tan theta is also approximately equal to theta. Now cos is slightly different, and again with this result here. If we draw the graph of cos, which looks like that, so remember at 0 it's 1, at pi by 2 it's 0, and we draw this graph, which is y is equal to 1 minus theta squared over 2, which looks like that, we will see for small angles up here that those two graphs coincide. So what we say for small angle for cos theta is approximately equal to 1 minus theta squared over 2. All right, so the results are for sine theta, for small sine theta, it's approximately equal to theta. For small theta, tan theta is approximately equal to theta. But for small cos, for theta of cos of a small angle, it's approximately equal to 1 minus theta squared over 2. You can see that there. Now this applet I will put as a link in the notes of the video. I hope you've understood, and I thank you very much for watching.